More context isn't more memory. Past a point, it's less. A bigger window doesn't fix a long task, it rots. Welcome to AI TechBook. Today, long horizon context, why a bigger window won't save a long run, and the 4 techniques that keep your agent sharp for hours. Here's the thing nobody tells you. As the context window fills, the model's ability to recall what's actually in it goes down. That's context rot. 2 reasons. The transformer builds in squared relationships across the tokens, so attention stretches thinner the longer the sequence gets. And models train mostly on shorter text, so those long-range connections are just weaker. Put together, you've got a finite attention budget, and every new token spends it. So tokens aren't free memory. Each one draws down the same budget, which means a bigger window is not the fix for a long run. And that changes how you have to think about the window. Here's the reframe. A context window is a budget you spend, not a tank you fill. If attention is finite, the job isn't to cram everything in. It's to keep only what matters in the window and put the rest somewhere you can pull it back. That's the one idea behind all 4 long horizon techniques. Compact, remember. Retrieve, isolate. 4 moves, 1 goal, spend the budget well. The first one handles the conversation that's already too long. Technique 1, compaction. The conversation is filling the window, so you summarize it and start fresh from that summary. You take the history, distill it in high fidelity, and reinitialize with the compressed version, so the agent keeps going with almost no drop in quality. Claude Code does exactly this. It preserves the architectural decisions, the unresolved bugs, the implementation details, and throws away redundant tool outputs. The guidance: balance recall against precision. Keep the critical stuff first, then trim the superfluous. And a safe first cut: clear the old tool call results. Once a tool ran deep in the history, why keep showing the model the raw output? Compaction keeps the conversation flowing past the limit. But some things you don't want to summarize away at all. Technique 2, Agentic memory. The agent writes notes outside the context window and pulls them back when it needs them. Instead of holding everything in context, it persists notes to memory. A to-do list, a notes file, and reads them back later. That's persistent memory with almost no overhead. And Anthropic's memory tool makes it first class. To greet the agent builds up a knowledge base over time, keeps projects stayed across sessions, and references past work without keeping all of it in context. The point: what lives in memory doesn't cost you any attention until you actually ask for it. Note-taking shines for long, iterative work. And the raw data? You don't load that until you need it either. Technique 3, just in-time retrieval. Don't preload the data. Keep a pointer and fetch it when you need it. Rather than loading everything up front, the agent keeps lightweight identifiers, file paths, stored queries, links, and loads the data at runtime with tools. Claude Code uses commands like head and tail to read huge files without ever pulling the whole object into context. It mirrors how we use file systems and bookmarks, and it explores progressively. File sizes hint at complexity, names hint at purpose, timestamps hint at relevance. The agent discovers its way into the context it actually needs. Retrieval keeps huge data out of the budget until it's worth spending. And for a big exploration, you can spend a separate budget entirely. Technique 4, subagent isolation. Run a big exploration in a separate window and return only the distilled answer. A specialized subagent works a focused task in its own isolated context. It might burn tens of thousands of tokens exploring, but it hands back only a condensed summary, often 1,000 to 2,000 tokens. The lead agent's window stays clean. That's a clear separation of concerns. The detailed search stays isolated in the subagent, while the lead just synthesizes the summaries, and on complex research, that's a substantial win. 4 techniques. So which do you reach for when? It's task dependent, and they compose. Compaction maintains conversational flow when one long thread is filling up. Note-taking excels for iterative development, where state matters across steps. Just-in-time retrieval is for large data you can't hold. And multi-agent architectures handle complex research, where parallel exploration pays off. And these aren't either or. On a long coding run, you'll usually compose 2 or 3 at once. Match the technique to what the long task actually needs. So what do people do instead? 4 mistakes. Each one fights context rot the wrong way. 1. Just use a bigger window. A million tokens still rots. Size isn't recall. 2. Never compacting. The window fills with redundant tool outputs until quality falls off. 3. Preloading everything to be safe. That spends the whole budget up front. 4. Top 1 agent for everything. A giant exploration pollutes the main window instead of being isolated. Every one of those is context rot, just arriving by a different door. Compact, remember, retrieve, isolate. Don't just inflate. So the verdict isn't use a bigger window. It's this: context is a budget you spend, not a tank you fill. Keep only what matters in the window. Compact the history, write notes outside it, retrieve data just in time, and isolate big explorations and subagents. Then pull each piece back exactly when you need it. Attention is finite, so spend it on what matters now. The whole thing, one screen. Context rot, recall drops as the window fills. Compaction, summarize and start fresh. Memory, write notes outside the window. Retrieval, keep a pointer. Load on demand. Subagents, explore in isolation. Return a summary. Context is a budget you spend. Keep what matters in the window, pull the rest back. That's long horizon context. If this made your agent's long runs make sense, share it with one person whose agent keeps losing the thread. Subscribe to AI TechBook. Next, the symptom side. Your agent loses the thread on long runs? Here's the fix.